Okay, then let's start the lecture. Let's continue the previous topic here. Last time I gave you some introduction and I tried to give you, let's say, a starter kit for your exercise class. In your exercise classes, you you surely need to use, for example, integer types, integral types, and strings. You also need to use variables. You should know how to declare a variable, how to initialize it to a variable, to a concrete value, and how you also need to read some input from the console and also to output something. So you also also learned how to use console read line and console write line. And finally, I think this is the slide where I stopped last time. Do you agree? Have Have you already seen this slide? Do you remember? So you don't remember, I guess. Okay, so let me give you some introduction to operators. Since in your programs you have variables and values, you definitely need to do calculations at some point. So these are the so-called numerical operations. You know them: addition, subtraction, multiplication, and division, the four basic arithmetic operators. And we have also one additional operator, the modulo operator. Have you ever used the modulo operator in C# or in other programming language? Okay. Okay, so here it is important, if you check out the yellow boxes, that if you divide two integer numbers, then the result will always be integer. However, in this case, the result will be something like 3 dot and some decimal numbers. But you should remember that whenever you divide two integers, the result will be truncated to an integer. Therefore, if for whatever reason you need to get the remainder or the modulo of that division, just use the modulo operator. Okay, other important operators which you need at the beginning is the assignment operators. Of course, you already know this basic assignment operator, the single equality sign, but I guess you also got to know the plus plus operator, which is about incrementing a variable by one, and the minus minus operator, which is about decrementing by one. So these are the basic assignment operators because they are about to assign a new value to a variable x in this case. Uh, have you used any of those operators in your exercise class already? No, you didn't. Okay. But soon you will, because soon you will use such an instruction, the if instruction, which works as follows. Here you put a condition, a true false condition, and the if instruction checks if this condition is true, and if it is true, then the instruction here will be executed, but only then it will be executed. If the condition is false, then this instruction is skipped. So you must be able to assemble a condition, and for this you definitely need relation operators. You want to check if, I don't know, two variables are equal, or x is less than the other variable, and so on. You know those relation operators from mathematics. Keep in mind, however, that in C# and also in many other programming languages, the equality operator is this double equality sign. So don't forget it, because if you exchange it with the single equality sign, it means something completely different. This is assigning a new value to x, and this is about checking the value of x. Okay, so this is important, but of course, if you uh, if you at some point you exchange them, the Visual Studio will warn you, so don't panic. Not equal is represented by exclamation mark and the equality sign together. You probably already know, because I remember you knew this in my lecture on logic, that the exclamation mark represents negation. I mean the not operation. So this is how you can check if two values are not equal. Okay, here I have something written in the green box. So it says that whatever x and y, I mean, whatever is the type of x and y here, the result will be either true or false. You see, because you need this true or false value, for example, here in the if instruction. So here these operators return a logic value, or in other words, a Boolean value, true or false. And this is another data type in C#, which is called bool. Soon we will learn about this type as well. Okay, so now you are able to assemble conditions here. For example, you can compare two variables with each other, but in most of the time you need not a single comparison here, but a compound condition. So, for example, if you develop an Android app, and this Android app has a registration screen where the user can type some personal data in, like his or her name, or password, or some identification number. Then after the user typed everything in, you have to check if every data is correct. For example, the name is not empty, the password is strong enough, the identification number is of correct format, and therefore here in the condition part you have to connect several conditions by using those operators, like what we already know from the logic class: logical and, logical or. You can also use negation. So those are the operators for those logical operations, and I assume you already know how they work, because we had this logic class together, as far as I remember. Yeah. So do I need to explain this, how they work, or you already know? Yeah, yesterday. Okay. Excuse me? Uh-huh. Okay. We already saw those slides in the previous class. I cannot really understand you. You are. Ah, okay, I see. Okay. Uh-huh. Okay. Okay, then some basic explanation here. So these are logical operators. So they are operate over logical values, or in other words, bool values, true or false. Negation or logical OR, of course, means that we flip the logical value. If you have a true condition, it becomes false, in the other way around. Logical AND is much more interesting. So if you have two conditions, for example, two comparisons, you can connect those by using logical AND. And well, of course, both conditions must be true together. This is what logical AND means. Only in this case, the entire condition will be true. If any of the two conditions are false, then the whole condition, the whole logical AND condition becomes false. Okay, logical OR is in the other way around. So it is true if any of the two conditions is true. It becomes false only if both conditions are false. So this is how they work. Okay. Okay, we will see. Okay, let's see this example here. Okay, so I'm using here an if instruction with a condition here and there. Please tell me if this first condition is true or false with respect to the values of A and B. Is this true or false? The first condition. True? Yes, I guess it is true because both conditions are true, right? A is less than 0, yeah, and B is not equal to 100. B equals to 10, so it's not equal to 100. So that condition is true. Since we are using logical AND, the result here is true. Okay, you are good. How about the second condition? False, definitely false, because the first condition is false already. Actually, at this point, we don't even need to evaluate the second condition because this logical AND immediately becomes false, right? But of course, you can also evaluate the whole condition if you want. Okay, great. So this is about the logical operators and also the if instructions. So let's talk about the if instruction. I already explained what it does, and I'm pretty sure most of you already know what the if instruction does. Uh, you have the if instruction also in other programming languages. In the previous lecture, you told me that you already know, some of you already know PHP or C++ or Java, as far as I can recall, or Python. So in all those languages, you have the same if instruction, basically, and they do the same. We check if the condition is true or false, and if it is true, then and only then the instruction will be executed. Inside the condition, as you already saw, you could use relation operators, logical operators, mixed. This is what the if instruction is about. Okay, there sometimes you not only need to execute an instruction only if the condition is true, but also if the condition is false. By default, the if instruction executes something only if the condition is true, but there is an extended version of the if instruction. If you use it together with the else instruction, then you can do such a case split in your program. I don't think any any I don't think I have to say anything else about this. Here is an example. No further explanation is needed, I guess. But I don't know if you already knew, you can use if and else in a how to say in such a batch format. So if you have several conditions to check and several instructions to execute, you can repeat the else instruction several times, or more precisely, as if instructions combined. So here we check the first condition first. If it is true, we execute the first instruction. Otherwise, we check the second condition. If it is true, we execute the second instruction, and so on and so on. And finally, if all those conditions were false, then we can execute this very last instruction. So this is a very nice way to do a case splitting in your program in several, by using several, as many arbitrarily many cases, basically. Has any of you used if as if in this way before in any programming languages? In what programming language? C++. Yeah, this is the same in C++. Definitely the same. Actually, this comes from C++. C++ serves as the foundation for C# and also for Java and JavaScript, for so many languages. C++ is a very, how to say, very hated, very similar. Yeah, they are very similar to each other because C++ inspired all those programming languages. I mentioned already, C++ is hated, but it's an inspirational programming language. Excuse me? Mm-hmm. Okay, then. So this is about if and else and the else instructions. I'm pretty sure soon you will use those instructions in your exercise class, very, very soon. A little bit later, you will use iterations or loops. So let me just mention one of the loops in C#, the while loop. I'm mentioning this now because it's actually very, very similar to the if instruction. It looks the same. The if instruction has a condition part and the instruction part, and this holds also for the while loop. What is the difference between an if instruction and the while instruction? What do you think? Okay, so the difference, yeah, yes, yes, that's it. Thanks, Ahmed. Right? You you answered this question. Great, exactly. So the loops and also the while loop is about repeating something, and as Ahmed just told us, the while condition repeats this instruction until the condition part becomes false. So in other words, while it repeats the instruction while the condition is true. So for example, you should use such a loop in your Android app I mentioned before for the registration form. So you should repeat asking the user to provide the personal information, all the personal information until he or she types everything in the correct way. So whenever has an error on the registration form, you should repeat asking the information again and again and again and again until the user gives the correct input. Therefore, I tell you, loops are one of the most important type of instructions in programming. Okay, here is a very similar example with a console application. So here, what does this do? So let's just start at the beginning. We assign -1 to the variable x, then we check this condition. Is this true or false? It's of course true. So since it is true, we go for the instruction. It is also called the body loop or the loop body. So now the loop body is enclosed by those brackets here, and the loop body now contains two instructions. So since the condition part is true, we start to execute those instructions. We write the console this message, and then we ask a new value for x. You already know those functions, readline and int.parse. Okay, at the end of the loop body, what do we do? We go back to the condition part. So here we jump back to the condition and we check the condition again. We check if x is not a positive number. If it is not, if it is not, so the condition is true, we start to execute the loop body again. So we again write to the console, type a positive number and ask for a new value. So this is very similar to the example I mentioned. We force the user to give a correct input and we don't let the user proceed until he really types the correct input. So this last line, last instruction only executes if the condition became false, which means the user typed the correct input already. Okay, if you have any question, don't hesitate to ask. Because this is the last slide in this slideshow. Okay, no question regarding loops and the if instruction. Then I would continue with my next slideshow. Okay, then. Oh no, this is not the one. Okay, guys, as I already told you, from now on, we will jump back, we will go back to certain, okay, let me finish my sentence, then I will answer your question, Oleg. So, during the semester, I will go back to certain topics I already mentioned in the introduction. For example, now we are going to talk about types. Types and including the int type and the string type as well. But there are so many other types, and actually there is so much to learn about types. And for example, I also will go back to variables or loops, but I will also teach about topics I have not mentioned yet. For example, how to generate random numbers, how to use array and lists, records and enums, how to implement methods. So there are much more topics. But at the beginning, I'm going to go back to already mentioned topics such as types. Okay, meanwhile, Oleg asks if C# has anti-loops. No, it has no until loops, only while. It has only while type loops. I guess by an until loop you mean that the loop repeats itself if the condition is false. In C sharp we have only loops which repeat themselves if the condition is true. Yeah, in some programming languages we have until loops. In what programming language you used until loops, Oleg? Pascal, of course. Yeah, good old Pascal. Yeah, in Pascal there is an until loop, but I cannot really recall any other programming languages. Maybe PHP. I don't know. PHP has until loops. Maybe it does. No, I don't think so. No, PHP does not have an until loop either. Maybe Delphi. Delphi. Delphi is the programming language which can be considered to be an upgraded Pascal. And yeah, Delphi programming language has an until loop. In C sharp, we don't have such a loop. Okay, later we are going to talk about loops much more. In C sharp, actually, there are 4 type of loops. Now I mentioned only one of them. If you are interested, just look this up before my future lecture where we are going to learn more about loops. So now let's continue with types, because types are really important in your programs. You definitely need data to use data, and every piece of data have some data type. So you should be quite confident about how to use types. Mm, yeah, in our logic class, I mentioned some accidents and incidents where some misuse of types caused, for example, a spaceship to explode. So you should be very confident about using types. This is why I dedicate a separate slideshow for types. This topic will be quite, well, not very, how to say, it might be difficult for you to enjoy this topic because it's not that enjoyable, but it's very important. Okay, let's start with something you already know. I mean, partly, or you already know. You already know that in programming languages there are numeric types, for example, int. There are text types such as string in C sharp, and also there must be some logical type in C sharp. This is the bool type, but also there are further types in programs. Of course, sometimes you need to store a date. I mean, year, month, and day, or time. And actually, in most of the programming languages, there are such compound types as well. For example, date types. We have a date type also in C sharp. And so many types. We have so many types in C sharp, or more precise, in the .NET framework. .NET framework is the programming framework behind the programming language C sharp. Okay, so those types are called the fundamental types, or basic types, or primitive types in programming languages, which you can also use to to construct new types. So very soon we will learn about how you can construct your own types if you need new types. For instance, just imagine that you want to implement a web shop for 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 what? For for used cars. Okay, so you have a used car shop and you want to develop a web shop. So for such a web shop, you definitely need to construct a new type for cars. Inside this data type, you will store, I don't know, the model of your car, the license plate of your car, the fact if it uses diesel or benzene, and so on. So you will put every necessary data inside your own custom type. Okay, I hope you can imagine that. Okay, soon we will learn how to do that. Now let's talk about basic types like numeric types, text types, and so on. Whatever type you use, there are important features you have to keep in mind. For example, if you want to store a value, a number, you should know how many bytes it uses. Every data is stored in the memory of your computer, in the RAM of your computer, and you should know how much space your data allocates. This means how many bytes it allocates. But that's not enough. This is only one feature. You should also know what is the meaning, how to interpret those bytes. This means the same. What is the semantics of your bytes? And consequently, you should know what is the value range for your data. Okay, so let's go deeper in this topic. We have two big classes of types. Now we are going to talk about the value types first, and most importantly about integral types. So these are the integral types in C#. You already know at least one of them, int. This is the most basic integral type, but we have already we have 7 more integral types in C#. Crazy, isn't it? 7. So you should know what the difference between them is and when to use an int or when to use a ulong, when to use an sbyte. This is what we are going to learn now. So how to start? Okay, there are several features written here. Let's look at the left side of the screen. Here you can see how many bytes type allocates. So this is an important feature, right? How many bytes are allocated. For example, int allocates 4 bytes in the memory. Or the byte type allocates only 1 byte in the memory. Okay, let's continue with this one. If you have a byte typed variable which allocates only 1 byte in the memory, the value range of this variable is between 0 and 255. This is what is important for you, for a programmer, right? To know what is the value range of my variable. So let me ask you, do you have any idea? Do you have any guess why this is the value range for this type which allocates only 1 byte? Any guesses? Okay, Oleg, wrote something, how should we interpret your answer? I think I know what you mean. Yeah. Okay. And yeah, so Oleg is right. So in a byte, we can represent 256 different values. So if you check out this value range, it has 256 different values inside, including the zero. Okay, the next question, where the 8 comes from. So you wrote here 2 to the power of 8 equals to 255. Where the 8 comes from? Anybody else knows the answer? Okay, Oleg already typed it. Yeah, exactly. So 1 byte includes 8 bits. Thank you. 8 bits. I guess all of you knew this, and actually you have another course parallel to this course, Introduction to Informatics. I think this is the name, where you learn about um, such facts about binary numbers and stuff. So yeah, 8 bits. Each bit, a bit has two values, true or false. So basically a bit can hold two values. If you have 8 bits, then the possible values is 2 to the power, number of possible values is 2 to the power of 8. Thank you. Okay, so mhm. So let's continue. Let's continue in this green column. Let's check out ushort, which allocates 2 bytes, and its value range is starts from 0 and ends at 65,535. Come on, where does this number come from? Who knows? Is there anybody else who knows that? Thank you, Oleg. Yeah, basically, it's 2 to the power of 8 and squared, which is equal to 2 to the power of 16. 2 to the power of 16, since in 2 bytes you have 16 bits. Okay, great. And the same, by following the same logic, you can calculate what is the value range of uint, which allocates 4 bytes, and ulong, which allocates 8 bytes. Well, for ulong, you can store huge numbers, very huge numbers. Okay, do you understand this green column, which is about unsigned types? Yeah, yes, unsigned types means they cannot represent negative numbers. So the left, the range starts at 0. So do you understand this column, all of you? Okay. Do you enjoy learning about this? Not that much, right? Because these are very dry facts. Okay. Okay, so far so good. So let's talk about the blue column, which is about signed types. Each unsigned type has a counterpart, a signed counterpart. Basically, if you look at the value ranges, you can make a value signed if you shift the range to the negative direction. So basically, you shift the half of the range into the negative range. So the half of 255 is 182, 128, for example. So the half of the range here, in the case of S byte, is located in the negative range. That's it. This is how you can create a signed type out of an unsigned type. And you see the same logic holds in case of short, in case of int, and long. So let's talk about int now. You always used, I guess, so far you used only the int type as a numeric type in your exercise class, where the range starts at about -2 billion, and the maximum value of the range is +2 billion, roughly. So here you can see why these numbers look like that. And yeah, so as I already told you, you should keep in mind what type does what is the range of those types, because it can be matter life or death. So it can be a matter of life and death to know, for the programmer to know what the types, how the types work in your program. So let me just open another slideshow from my logic class, and since Destiny was not here, let me mention this incident again from the 90s, where a spaceship exploded only because a shitty programmer misused types. So this programmer used a 16-bit, or in other words, a 2-byte type. So probably he or she used short. This is a 16-bit type. And on the other hand, he or she thought he was using a 32-bit type. So, for example, an integer. It's a very huge mistake. Just imagine you declare a short variable whose range starts from minus 30,000 and ends at plus 30,000, and at the same time you think you use an int variable whose value range is starts at 2 billion and ends at plus 2 billion. So this can cause very serious problems, which we call overflow. And well, in this particular case, yeah, I already gave you a spoiler. The rocket exploded only because of a shitty programmer who didn't know how to use what types do. Maybe the shitty programmer didn't attend one of the first programming classes at university, or I don't know, and he caused, or she caused several hundred of millions of dollars loss. I also mentioned in my logic class another incident. It happened 5 years ago, a very similar bug, where in this case, I think, who gave me yeah, somehow gave me Ahmed. Ahmed gave me the, yes? Yeah, Ahmed gave us the explanation what happened here, probably what happened here. So here, probably, the shitty programmer used an integer an integer type, a 32-bit type, whose maximum value is roughly 2 billion. And then in the software of this airplane, the programmer used a counter and increased the counter every time. And when it reached 2 billion, just overflew, and then the system automatically shut down. So if the programmer, the shitty programmer, attended the programming class and listened to the teacher, he or she would be used, first of all, an unsigned type. That would be a good idea, because in this case, you only have to calculate how many time, how long, how many how long time already passed. So of course we don't have to go to the negative range if you calculate time. So why didn't he or she use uint? Or even better, just use ulong. Why not? With ulong, the range is so huge. It would take very long for the system to overflow. Okay, so it really matters what type you use in your programs. Do you have any question regarding those 8 types? Mhm, mhm, mhm. Yeah, this might be the explanation. Well, 5 years ago, I guess they already had such uh, how to say, more, yeah, more powerful computers. Yeah, you might be right regarding this other incident from the 90s. However, I don't think back then computers didn't have 32-bit uh, arithmetics. I don't know, but maybe you are right. I don't know. But anyway, as the picture shows, it would have been a good idea to upgrade the computer system, the computer hardware as well, because they really needed at least a 32-bit type here. Yeah, but you are right. It really depends on the platform you're using, the hardware you are using. You are right. Anyway, if you program in C Sharp, it is guaranteed for you that all of those types are supported, whatever hardware you are using. Actually, this is very good news. So you cannot make such a mistake if you use C Sharp, only if you are really a shitty programmer. Okay, is there any other question or comment? Nope. Okay, then here is an exercise for you. So I'm eagerly waiting for your answers and suggestions. Here, let's suppose I'm still a shitty programmer and I know only the int type. However, in most of the cases, it would be advantageous to use smaller types, or sometimes it is needed to use a larger type. So let's start with the third one. Okay, so here we have a variable called grade. So probably it's about to store a grade in schools, which can start with 1 and end with 5. Or I don't know if in your countries you use another grading system. Anyway, yep. what, how does it work in Egypt? I see, I see. Okay, so you are talking about how many years, for example, elementary school uh, takes. Yeah, okay, thanks. I wanted to talk about the grading. Yeah, exam grades, exactly, or test grades. In Hungary, we use one, two, three, four, five. These are the grades. So how about in Egypt as well? Really? Huh, okay, 100. Mm-hmm, mm-hmm. Okay, interesting. Mm-hmm. Okay, Oleg also wrote that in Moldova the grading system is between 1 and 10. I also heard about other countries using the same in Hungary. Yeah, Morocco. Okay, interesting. Higher resolution. Okay, as you know, in the US they use range between A and F, so it depends on countries. Hmm, 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 maybe. So let's suppose in this example we want to store Hungarian grades between 1 and 5. So which type should I use here? I mean, int is okay, but it seems a little bit, you know, overreacted. So in int you can, yes, okay, I'm not continuing my sentence. Yeah, let's use byte because basically we don't need a negative number, and this maximum number is completely enough. So let's use byte in the third case. So what do you suggest in the first and the second case? What type would be better here in the first case? So here the value is roughly 30,000. Yeah, U short. I would use U short as well. Well, it depends, of course, depends on, of course, if you want to change this value later, because this is a variable, so you are able to change the value. If you don't want to change the value to a negative number, then U short is pretty good. How about the second one? Minus 500. Which one? Short, short, yeah. Because it's a negative number, so we definitely need a sign type. Unfortunately, S byte is not sufficient because we have minus 500 now, so short is the minimum type we need here. I suggest you to use minimum types because you can save memory. Of course, on a PC, this number of bytes is not, that doesn't really count, but as one of you mentioned, in some on some hardware it can really matter if you can save bytes in the memory. Okay, let's talk about the age of Earth, which is roughly 4.6 billion years. So here, actually, if you type this instruction in Visual Studio, here you get an error message because int is not sufficient for such a high number because, you see, yes, definitely u long. So in int, the maximum value is plus 2 billion, which is not enough here. So you can change to uint, where the maximum number is 4.2 billion, but that is not sufficient either. So therefore, you were right. U long is the good choice here. In a U long, this even higher numbers can fit in. Okay, and here we have the last example. Short. Oleg also suggests to use short because, yeah, x plus y is, I don't know, it's about 30,000 again. So here, well, we could use also u short, of course, but again, these are variables, so it might happen that you change their values, and you could change the value of y to a smaller negative number as well. And yeah, well, if you add a u short and a short, the result can be a negative number as well. Therefore, I would pick short as well. Interesting, if you try to type this in Visual Studio, you get an error message. And it is a good question, why? But at this point, I cannot answer this question to you, but maybe you have an idea. I'm just mentioning this. Later, I will come back to this problem and I will explain what is the reason here, why this doesn't work. Right now, I just want to share you this practical solution. So whenever you get a syntax error when you try to do something similar, you can force the C# compiler to accept your decision by inserting the target type in front of the expression. So here I have an expression x plus y. I would like to force the result of the summation to become short. And this is how you can do this. Just put the type in front between parentheses. This is what we call type conversion or typecasting in English. You can use any type in front of expressions between parentheses. This is a quick fix if you face to a similar problem during your exercise classes. And sometimes this works. Most of the time this works, not always, but most of the time this works. Yeah, well, Oleg, yeah, the explanation here is much more complex, not that easy. Therefore, I'm going to come back to this topic later after we learned more about types. But of course, if you want, you can look this up in the internet and you might find some information. We will come back to this point. Okay, thank you for your help, and let's continue with floating point types. So far we learned about integral types only. There are 8 integral types in C#. Yeah, and before moving to the next kind of types, let's just check out other programming languages. So for example, as we already learned, Java is very similar to C#. So let's check out what integral types that Java provides. Okay, so here you can see a table with Java types, and actually only the first 4 of those types are integral types. So in Java there are only 4 integral types. In C# we have 8. If you check out them, well, they have very similar names. The sizes are the same, completely the same. There is only one difference. What types are those? If you check out the description part. Discrete? No, of course not. We are talking about integral types, still integral types, integers. So they are also integers, discrete numbers, you are right. But my question is why Java has only 8 integral types while C# has, why Java has 4 integral types and C# has 8? What is the difference here? Something is missing from Java. Yes, more precisely, unsigned types. Java does not have unsigned types, only signed types. You see, all the ranges. Okay, all the ranges start from a negative number. So in Java, you couldn't use a unsigned type, for example, grades or the age of Earth, or for you couldn't use an unsigned type here inside the software of this airplane, which is stupid because if you start counting from 0 and increment something, you definitely don't need negative ranges. So actually I think it's really good in C# that you have unsigned types as well. But this is my opinion. Java's type system is simpler a bit. That's the other side of the story. Okay, let's just check out C++. You mentioned C++ before. Let's see what's the situation in C++. Okay, so this is the full table. Oh, come on. Okay. Okay, so here it is. So in C++, there are so many types. Just look at this. So many types, and these are all integral types here. Crazy, isn't it? So let's just analyze this. First of all, in C++, we don't have a byte type, or actually we have, but it's called char or car. It allocates only 1 byte, so it's completely the same. We also have an int type, which allocates 4 types. So these are quite the same. But here is something different. So in C++, there is no dedicated name for unsigned and signed uh, counterparts of types. Rather, we use such prefixes, unsigned and signed. Actually, I like this. I like this style. Just put one of those prefixes in front of the type, and you are done. Like unsigned int, signed int. This is really nice. Okay, we have other prefixes. For example, short. So you have to use short together with int, not by itself, uh, as opposed to C sharp. Well, okay, why not? So short int is a 2-byte type. Of course, you can also use it in an unsigned or sideways. So now we have two prefixes already. And also you can use the long prefix. This is how you get 8-byte types, sorry. And well, this looks really interesting. You can use long twice. Excuse me? Yeah, Chinese name. Oh, that's funny. Yeah, exactly. Chan, long. Cheng, long Cheng. Yes. Okay, but this looks strange. So if you look at long int and long int, they have the same sizes and actually the same ranges. These are completely the same, but in other format. So this table, there is something wrong with this table. Let's look at another web page. Okay, this looks interesting. So here you can see the C++ types again, and they start with short int. Okay, if you look at it, this is very interesting. The C++ standard does not fix the size of the type. It only declares the minimum size. It says at least 16 bits, so at least 2 bytes. And actually the same holds for int. Int has also this minimum size. Long has a minimum size of 4 bytes, and long int has a minimum size of 8 bytes. This is interesting, and this relates is connected to what you were talking about, different hardware. If you implement something in C++, you cannot be sure what is the size and the range of your variables, because it really depends on the hardware and the operating system you are using. This makes programming in C++ very difficult sometimes, but also it can be very effective, because you can really adjust your program to the hardware and the operating system you are using, so you can save memory in a very nice way. But it's extremely difficult to be a C++ programmer, also because of this. Good news for you that in C# you don't have such difficulties. Whatever hardware you are using, whatever operating system you are using, types are the same, type sizes and ranges are the same. This is very nice. I mean, convenient. Okay. Okay. Let's check out one more programming language, Python. I can tell you, this is a spoiler, type system in Python is completely different, and actually in almost all the script languages such as Python, JavaScript, Ruby, and those languages, type system is completely different compared to type system in C++, Java, C Sharp. Okay, just look at, let's check out Python. So in Python, we have only 3 numeric types, and one of them is int. So we have only one integer type, not 4 or 8 or 20, 24, such as in C++, but only one int. So you don't even need to keep in mind what is the size of this type, or do you? So let's see. I think here I found a web page about the size of this type. Okay. Here it is. So in Python, there is no limit how long an integer value can be. No limit. So you can use billions of billions of billions of billions. The Python interpreter will be able to deal with it. This is very interesting because the Python interpreter uses a radically different mm, way of storing the integer value. Actually, it uses not that effective way of storing the value. In C# or in C++, it's really effective. In Python, it's not that effective, but on the other hand, there are no limits. You can use arbitrarily large numbers. Interesting, isn't it? Okay, let's move to the next. Oh, soon I'm running out of time, but I would like to finish with floating point types. This is not that easy, but let's try to understand it in the last 10 minutes. I hope you are with me. So, one of you already mentioned that sometimes we need decimal numbers or fractional numbers, like this one here, with a decimal dot between, inside. So, how can we store such a value in C# or in any other programming languages? We use this way of representing such a number. So first of all, we move the decimal dot to the end of the number. This is how we get an integer number. We call it mantissa. This is a strange word. Okay, but of course, how can you move the decimal point number? Well, you have to multiply the number, the original number, with such a power of 10. Now we need to multiply it with the 10 to the power of -4. This is how you can move this decimal point number here at the end. Okay, so whenever you are about to store such a the decimal number, or this is the official name, a floating point number, you have to store the mantissa, the exponent, -4 here, and also the sign of the number. Now this number is positive, but it could be negative as well. Therefore, we use a sign bit in front. The sign bit can be either either 0 or 1. If it is 0, then we store a positive number. If it is 1, we store a negative number. Okay, so sign bit in front, then the exponent, for example, -4 now, and only then in the remaining space you will store the mantissa in the red bits. In your other class about the introduction to informatics, you will learn much more about how to represent floating point numbers. Now I just wanted to give a short introduction. Anyway, in programming languages such as C#, you can use two floating point types. So these are the two floating point types in C#. First of all, the float type allocates 4 bytes in memory. The double type uses double space, so it allocates 8 bytes. So basically, this is how they are stored in memory. As if you check out this, the simple floating point type uses 8 bits for the exponent and the remaining 23 bits for the mantissa. Why? When we use the double precision floating point type, double, we have 11 bits for the exponent and 52 bits for the mantissa. So you can find those information here, 8, 11, 23, 52. But this is not that important in practice. What is important is the precision. How many decimal digits you as a programmer are able to represent. If you use the simple float type, you can use only 7 decimal values after the floating point. With double precision, basically you can use the double. You can represent the double number of decimal digits. Okay, do you have any question regarding those two types? No. So last slide for today. Soon in your practice class, you will be forced to use floating point numbers, like this one, minus 1.56. You can store such a number in either a float variable or a double variable. Now I'm using double, and this is intentional because in C#, the default floating point type is double. If for whatever reason, even if you look at this number, it's quite obvious that float would be quite sufficient because we have only 2 decimal digits, so the float type is quite sufficient to store such a value. But if you change this double to float, the Visual Studio will throw an error message to you. Why? Because here the default type is double. If you want to force your value to be represented as a float, just put the F suffix after the value, and then it will be interpreted as a float. I just wanted to mention this to you because this is also a source of errors if you don't know about this default double type stuff. So this is how you can solve this problem. Okay, one more thing, one more error which you might face too pretty soon. Again, division. So as I already mentioned today, if you divide two integers, the result becomes integer, even if you use a double variable to store the result. The problem is here that the result itself, when it is calculated, will be an integer number. However, now the real result should have been something like that. But whenever you divide two integers, the result will be truncated to an integer. Therefore, here is my suggestion to you. If whenever you need to fix this issue, just make at least one of the numbers, turn one of the numbers a floating point number, for example, like this. This is now a floating point number, so the result will be also a floating point number. Okay. Okay, last sentence about floating point numbers for today. In C#, there are so many calculations you have to do over floating point numbers, and typically over doubles. For example, if you use something from the math class, such as pi, everything in the math class is represented as a double because, of course, we want to use the higher precision when we do mathematical calculations. Okay, guys, that's it. I will continue with the remaining types. I have actually 2 slides left from this slideshow. No, okay, maybe more. Anyway, so here I would like to stop and I would like to mention something else similar to the logic class. Uh, in the beginning of each lectures, we will do a Kahoot quiz. Yeah, try to download the slideshow slide, try to check them out again, try to learn what we were learning, what we have been learning during those 2 lectures, and next week we will play a quiz together. Okay, so then enjoy your lunch, or you actually, or maybe you already did. Now I'm going to enjoy my lunch. So see you next week. Have a nice weekend.